So hello students, how are you? Good evening. So we are here with our continuation in revision of class 12 physics, and this is a revision class number 2 of current electricity. In the previous lecture we have seen uh, the basics of current electricity, current density, what is current, the flow of current, how the conductor behaves in the external electric field, and what is the drift velocity, what is current density in terms of drift velocity. We have seen the explanation of Ohm's law in different forms, and also tried some PYQs. We have deeply understand the effect of resistance and the temperature effect on resistance and resistivity. So now this is the revision class number 2 regarding current electricity. So the leftover topics that we have left, we will cover it by today. So let's just get started with it. So today we are going to cover the combination of resistor. We will see the method of symmetry also. Potential difference and EMF we are going to understand. Then the combination of cells itself. Kirchhoff's law, the important thing we are going to discuss. Then galvanometer, ammeter and voltmeter. Wheatstone bridge and meter bridge. These are the electrical devices that we are going to discuss today. So without wasting so much time, let's just get started with it. So firstly, the combination of resistor, there are only two combination possible, which is the combination of series and combination in parallel. In series, the one of the end, if this is end number 1, this is end number 2, this is end number 1 again, this is end number 2. So the end 2 is connected to the end 1 of the resistor. This combination is called as the series resistor, series combination. The property of series resistance is that if you focus on the current, this current will flow through this R1 also, and the same current will flow through R2. So in series, current will remain same. Current will remain same. Okay. But if you talk about the potential difference, here, if you want to measure the potential difference across this resistor, so you have to measure it parallelly. You will see at this end to this end. What is the potential difference? Let's say V1. Because there is different resistance, so there will be different voltage across these resistors. So in this combination, the voltage across the resistor will be different, but the current will be same. We can say that current will remain same, but potential difference across the resistor, across the resistor is not same. Okay, if we are going to then the very basic question from these topics will be the R equivalent. Okay, the R equivalent has to be asked that what is the equivalent resistance between uh, point B and point A. Okay, so if they are in series, we know the Ohm's law is V is equals to IR. Okay, for V1, the potential across R1, it is V1 is equals to same current I into R1. And for potential difference V2, it is I into R2. Okay, we know that the total potential along A and across A and B will be V. Let's say V voltage battery we have applied across it, and the potential difference across R1 is V1, potential difference across R2 is V2. So we know that V2 plus V1 is equals to capital V. Okay, the voltage that we have supplied, that is the total voltage V. The sum of the voltage across R1 and voltage across R2 will be V. So from this equation, we can say that if we put these values, put the value of V1 and V2, it will become IR1 plus IR2, and we can write as VI into R equivalent. Okay, if I calculate the equivalent resistance, so this would be the potential difference across that equivalent resistance, and the current flown through that will be I. So it is IR equivalent. So from that equation, you can say that R equivalent in this case is R1 plus R2. Okay, so this is the equivalent resistance in series. You simple take the resistor, add them, so you will get the equivalent resistance. Now, the one of the question that can be asked is the potential difference, because current is same. So there is no point to ask current. Okay. So they can ask you about the potential difference across R1, potential difference across R2. So how to calculate that? So V1, we know that from Ohm's law, V2 is equals to IR2. So we can say that V is directly proportional to R. So from that equation, we can say V1 is equals to, this is the uh, formula to calculate the potential difference in series across the resistor. So V1, you will take R1, this one, if you want to find out the potential across R1, to take R1 divided by R1 plus R2, multiply with total voltage. Okay. Same for V2, it will be R2 upon R1 plus R2 into. So these are three formula you will keep in your mind, and this will definitely help you to solving questions. Now, combination of resistor in parallel. So for parallel, if you will see, the current will distribute to this branch and this branch, which means current will not remain same this time. Although if you talk about the potential across it, so it will be same, the potential across B and potential across A, because this end is connected to the positive end, let's say, and this end is connected to the negative end. So same thing is happening here. Okay. Potential difference in this case will remain same, but the current will be different. Because if you want to measure the potential difference across R1, so you will take this end and this end. And if you want to measure for across R2, so definitely you are going to take this end and this end. So this is not nothing but the end B and end A. So the potential difference across R1 and R2 in parallel combination will remain same. So we can say that potential difference will remain same. Current will be different. Okay, so two entities we have, physical quantities. One is the current and another is the voltage. So in parallel combination, voltage is different. In series combination, current is in voltage combination, current is different, and in series combination, voltage is different. Okay. So if you want to calculate the equivalent resistance of it, so the formula is 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. And if there are multiple of resistor, you can add them, take the inverse of them and then add. Now, most of the student will do a silly mistake in this equation. Whenever they calculating the 1 upon R equivalent, let's say for example, this is the circuit we have, and let's say this is 5 ohm and this is 10 ohm, and we want to measure the equivalent resistance across AB. So we can say that same end of the resistor are connected to the same end. So this combination is parallel combination. So 1 upon R equivalent here is 1 upon 5 plus 1 upon 10. 1 upon 5 is nothing but 0.2. Then this is 0.1. So it will become 0.3. So they left this. They left the answer, and there is definitely a option 0.3 ohm, and you will tick that and you will wrong. Why? Because this is 1 upon R equivalent. So for R equivalent, you have to inverse this. So R equivalent will become 1 upon 0.3, which is 10 by 3. Okay. So try to avoid these silly mistake. Okay. I have already told you what can be possibility. So here the current is different. So we are going to calculate, because in question there may be chances that they can ask about the current in different resistor. So same thing we are going to follow from Ohm's law. V is equals to IR. So we know that I is inversely proportional to R. So if you want to interested in calculating the current across R1, so you have to take R2 in the numerator. And for that, if you are interested in I1, so you have to take R2 divided by R1 plus R2, because they are following inverse proportionality rule. Multiply with the total current. Similar for the I2, you will put R1 on the numerator, R1 plus R2 into I. So these three formula in this also. Now, this is the combination of resistors. This might be a trick question for you. So in this question, this is also termed as the horizontal symmetry or vertical symmetry. So if you see this combination, the by looking at just at it, you cannot say these are then in parallel, because this resistor would come across it, and this is parallel. So nothing can be predicted here. But what we can do, if we draw a line crossing A and B, so we can say that the resistor above this line will be same below this line. So this is simply the mirror image of this part. Or it is very simple. If you calculate, if you just fold this part onto the upper part, so you will get the same pattern. So this resistance would be calculated as, like, this is point A, then this is the resistance, and now these resistance, because if you see in between A and C, only 4 ohm resistor is there. Between A and D, the 4 ohm resistor is there. So we can say these resistance are in parallel, because there's the same potential drop across AC and same potential drop across AD. So these two are superimposing on each other. You can say if you just fold it, this 4 ohm resistor will superimpose on this 4 ohm resistor parallel. So this is a parallel combination of resistor across this line of symmetry. Okay, so this 4 will superimpose on this 4, and they are in parallel. So we can say that 1 upon R equivalent is equals to 4, 1 upon 4 plus 1 upon 4. So it will be R equivalent directly 4 into 4, 4 plus 4. So give me just 10 seconds. Okay, sorry for the technical glitch. So here we are talking about the R equivalent. Now R equivalent will become 16 divided by 4 plus 4 is 8. So it will become 2 ohm. So finally this will become 2 ohm resistor. Okay, same thing will happen with this. Got it? Same thing happen with this branch and this branch. Same thing happen with this branch and this branch. Same thing happen with this branch and this branch. Got it? So this type of question is of horizontal and vertical symmetry. So what you have to do, draw a line of symmetry. Okay, so that the resistor, the combination of resistor appear as a mirror image of each other. So if you take this line AB, so this 4 ohm is the mirror image of this 4 ohm. This 4 ohm is the mirror image of this 4 ohm. This 4 ohm is mirror image of this 12 ohm. Okay. And same goes for these also. Got it? So now, so you can apply this method, and these resistors are in parallel. So finally, this question we have the equivalent resistance of resistor in a series combination is smaller than the least resistance used in the combination. Second statement is the resistivity of the material is independent of the temperature. So this is wrong, because resistivity depends on the temperature. In the previous lecture, we have seen that rho is equals to rho naught 1 plus alpha into T minus T naught. So it will depends on the temperature. So this statement 2 is false. Okay. Now you can also apply the logical reasoning here. If statement second is not is false, so find out the question option. Statement one is true, but statement second is false. This one, both statement cannot be true because this is false. So this cannot be the answer. Both statement one and two are false. ये this is the possibility कि ये भी false हो जाए, तो दोनों false हो सकते हैं. Okay. But this is not the priority, so you will reduce the number of option. Only this two you have to search. Okay. Now in the statement one, what is has to be said, the equivalent resistance of resistor in series combination is smaller than the least resistance used in the combination. So we will take it with an example. Let's say we have take three resistor 1 ohm, 2 ohm and 3 ohm. So the R equivalent here is 1 plus 2 plus 3, which becomes 6 ohm. And in the statement, it is given the equivalent resistance of the resistor in series combination is smaller than the least resistance used in the combination. So according to the statement, this 6 ohm should be less than to this 1 ohm, because this is the least resistance we have used. So this is incorrect. So we can say that this statement is also incorrect. It means statement 1 and statement 2 both are false. So option C is the correct option. Hello student. Hello JNU Nizamabad student. How are you? Now, why you have joined late? Because the timing of the classes is from 3 p.m. Is there any issue with you? Issue with your internet or anything else? So what kind of issue you are facing exactly? Tell me. Meanwhile, I'm discussing this question. Okay, power. Got it. So don't worry about this. Uh, I'm not saying that don't worry about the power. Don't worry about the discussion that I have did, because it will be in recorded form, so you can watch it later. But what I have covered is only the combination of series and parallel resistance and method of symmetry also. So this is not a big problem for you. And although you will get a recorded lecture, so you can watch there. But please uh, attend the class on time, and it's a goodness for you. Okay, as a betterment of you. So focus on this question. Different combination of three resistors of equal resistance capital R are shown in the figure. The increasing order for power dissipation is. Now, in the previous lecture, we have did that power is nothing but I square R, or V square upon R. But here only current and resistance is given, so we will use this form of power formula. Now, in this way, you can say that P is directly proportional to R if I is not changing. So in option A, option B, option C, and option D, the same current is to be flown through the circuit. Okay. So if the resistance goes up, the power will goes up. So we have to find the equivalent resistance and see, and in which case the resistance would be high. So in that case, the power will be high. Okay. Very simple question. And it is asked in JEE Main 2023. Okay. So that kind of question you can expect in JEE. That definitely improve your score and rank also. So if I take this example, sorry, this option A and B, option A. So these two resistors are in parallel. This is the parallel combination when the same end of the resistor connected to the same end of the another resistance. Okay. So this will become R plus R. So it will become R by 2. The equivalent resistance will become R by 2, because in parallel R 1 upon R equivalent is 1 upon R1 plus 1 upon R2. If you put the value, it will be 1 upon R plus 1 upon R. So it will become 2 upon R, and it is 1 upon R equivalent. So R equivalent here will become R by 2 in case 1. So it is R by 2 into R by 2 into R. Now this is the series combination. Second end of this resistor is connected to the first end of this resistor, or one of the way to identify that is current in this will be same. Okay. So now the equivalent resistance will become R equivalent is equals to again R by 2 plus R. Okay. So it will become 3 by 2 times R. In case A, we have received the equivalent resistance is 3 by 2 R. In this case, if you talk about this R plus R in series, so it will become 2R, and this 2R and R will be in parallel. So we can say directly 2R into R. Then this is valid for only 2. If two resistance are in parallel, you can use directly this formula. R equivalent is equals to R1 R2 divided by R1 plus R2. Now put the value R1 and R2. So here these are in series. So equivalent resistance would be 2R. In the parallel combination of this R. So 2R into R divided by R1 plus R, which is 3R. One of the R will cancel out. So it will become 2R by 3 in case B. Now in case C, there are in parallel. So 1 upon R plus 1 upon R plus 1 upon R, 3 upon R will be there. And if you reverse it, in case C, it will become R by 3. In case D, they are in series. So in D option, it will be the equivalent resistance is 3R. Okay. So in the option, you can see in the option A, in this option, the equivalent resistance is 3 by 2 R, which is 1.5 times of R. In case B, it is 2 by 3, which is 0.6 R. In case C, it is R by 3, which is 0.33 R. And in case D, it is 3 R. We know that power is directly proportional to resistance here. More the resistance, more will be the power. So in case D, we have more resistance, so more power will be dissipated there. So power of D will be greater in everyone. Then if you compare these three, 1.5 means option A will take place here. Okay. So, okay, very good. You are saying that option D is the correct option. Let's see. So then option power in A will be there. Okay. Now, then if I talk about these two, so 0.6 R, which means more power will be dissipate in this option. And this is option number B. Okay. So power will be in B. And then obviously power in C. So you can say that power in C is very, very less than. Then we have power B, then power A, and then power D. So option B is the correct option. So what you are saying, option D? No, option D is not the correct one. Correct one is option B. Got it? Clear with the question? Any kind of doubt? Now try to solve this question. Or I will discuss this question after the discussion of Wheatstone bridge, because this question is simple from Wheatstone bridge. Okay. So I will discuss it later. Meanwhile, you can solve it. Now, look at this question. This is very important question and conceptual question also. So in this question, there is a combination of resistor is given, but you cannot say this is in series or parallel because of these wires. Okay. So these are the wires that is connected through this. Two wires we have connected. We have to find out the equivalent resistance between A and B. So try this question. I will tell you the concept behind it. When we connect a wire across the resistor, the potential difference across the wire will remain same, will become same. The wire will become same. So this concept we are going to use. Now, in this question, let's say this is simply we can remove the end A from here and we can put A here. No problem in that. Similarly, we can do it for B. So this is A and B. Now we have connected this wire with this also. So we can say that the potential, whatever the potential we have at A, the same potential we will have at D. Okay. So the potential difference across VA and VD will become same. So if you will see this resistance, if you will see, so one of the end is connected to this, or one of the end is connected to this, but there is a wire. So because of this wire, the potential at C will become potential at B. Because in wire there is no resistor, so no potential will be dropped in the wire. Okay. We are not talking about the internal resistance of the wire itself. But for ideal case, the wire is resistanceless. There is no resistance in the wire. So whatever be the potential, same potential will be transferred here because there is no resistance where the potential can drop. So potential of B, you can consider it potential at C. Similarly, potential at A, you can consider potential at D. So if you will see this 20 ohm resistance, I have taken this 20 ohm resistance, and this is, let's say, AND A. So one of the AND is connected to AND A, and this is AND B. So we can say one of the end of this resistor is connected to AND B because potential at C and potential at B is same. So we can say that. So it is 20 kilo ohm. Now, if you talk about this resistance, so this resistance 20 kilo ohm, one of the end is connected to C. C means same potential at B. We can say that one of the end of this resistor is connected to B. Now, one of the end is connected to at D, but potential at D is same as potential at A. So we can also connect it with potential A. So this is also 20 kilo ohm. Now, if you talk about this 10 kilo ohm resistor, one end is connected to D, and D is nothing but the A because potential at D is same as potential at A. So one of the end of this 10 ohm is connected to A itself, and this end is directly connected to B. So no worry about that. So here this is connected to B. Now this circuit will reduce in a simpler circuit. These three resistance are in parallel combination. Now you can easily find out the equivalent resistance. 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now 1 upon R1 is 1 upon 20 kilo ohm. Since these three are in also kilo ohm, so we will consider it 1 by 20, 1 by 20 and 1 by 10. Okay, 1 by 20 and 1 by 20 will become 2 by 20, which is 1 by 10 plus 1 by 10. So you will have 2 by 10, it is 1 by 5, and this is 1 upon R equivalent. So R equivalent will become 5 kilo ohm. Okay, so 5 kilo ohm is the correct answer. Now the similar question is this. These three are in the series, these two are in the series, these two are also in the series combination. Then these two and this one are in parallel combination. So it is for you, it is for homework. So try to solve this. All the concept that is needed to solve this question I have discussed with you. You can draw a line of symmetry and we cut it here. So you can remove this junction. So this resistance, I will show you. This circuit will reduce in. This circuit will reduce like this. You can open this branch from here. You can open this branch from this junction. Also, this is 2 ohm. So you can open this branch because of the symmetry of it. Okay, and these two are connected to AND B. This is AND A, this is AND B, and the same thing we will have here. Now put the value and calculate it. These two are in series, this is in parallel, these two are in series again, these two are also in series. Okay, and then these three will become in parallel. So what you have to do, you will draw a line between A and B. So the same thing you will see here and there. Method of symmetry you can apply, and you can open this branch from here and calculate the equivalent resistance. Okay, so this is the homework for you. Try to do it now. The answer of this question will be 2 by 3. Now potential difference and EMF. Now these two are the same term but for different context. Potential difference, we can say that EMF is also equals to potential difference, but in a particular situation. Like this is the battery, these are positive and negative electrode, or you can say this is anode and this is cathode. So current will be flown from positive to negative terminal. So this is the current, this is load resistance we have applied, and this is the electrolytic solution of battery. It will be H2SO4 sulfuric acid basically. So what is happening in electrolytic solution? There is a, if you talk about the conductors, the metal, only the free electron is responsible for the flow of current. But if you talk about a battery, in that we have an electrolytic solution. In electrolytic solution, both the positive and negative charge ion will move. Okay. So when there is no load resistance is applied to a battery, okay, let's say this is the battery and there is no resistance applied across it. Got it? So if there is no resistance, which means the circuit is open, these ends are open, so no current is supplied. In that case, the potential of the battery that it can supply, the maximum potential that it can supply, is termed as the EMF of the battery. EMF is when no load is applied. Okay, so whenever no load is applied, you can say that potential difference is same as the EMF of the battery. But whenever we have applied a load resistance and the current will start flowing through it, then V we can say is equals to I into R. This is the potential difference. Potential difference. So you will have to keep one thing in mind. If there is no load resistance is connected, which means circuit is open, in that case the potential difference across anode and cathode is termed as the EMF of the battery. Got it? But whenever we applied the load, in that case the potential difference across P and N is termed as potential difference, not EMF of the battery. One of the things that you should remember, that if we have a battery, so there will be some small resistance with it within the battery. Because of this electrolytic solution also, it will provide some resistance to flow the current. Okay, so this resistance which is provided by the battery itself is termed as R, and let's say EMF of the battery is E. So if there is no current, we can say that potential difference is equals to EMF, and EMF is nothing but electromotive force. Motive force, the force that we require to flow the charge. So in this case, the potential difference or EMF will be E. Okay, only for this case. But when the current has start flowing, this is R, and let's say the current is flowing in this direction from negative terminal to positive terminal. So in this case, the potential difference across this, let's say this end is A, this end is B. So potential difference across AB, VA minus VB, you can say it is E minus IR, I small r. So potential will be drop in this case. Okay. If the current will flow in opposite direction to it. So this condition is nothing but the charging condition. This is discharging. Battery is providing the current. In this case, we are providing the current to battery, which means we are charging the battery. So it is E into R. So VA minus VB here, let's say this is A, this is B. So VA minus VB is equals to E plus IR. Now this resistance is gaining potential. Okay, so you do not need to worry about the sign convention, because whatever the sign you will choose, in the end of the question you will get to know that I have choose the wrong one, because there will be a minus sign. So you can rectify your error there. So do not worry about it. Although if you move with the convention, it will be easy for you to calculate the. Okay. Okay, chemical energy to electrical energy. Yeah, the purpose of the battery is to convert the chemical energy of that particular chemical into electrical energy. Okay, very good. So this is the purpose of the battery. The battery is a device which converts the chemical energy into electrical energy. Got it? Now, combination of cells. Now, we can also arrange the cells in combination. If in your childhood you have definitely everyone bought some toys, the racing car, the JCB and all. So in that case, in that particular toy, if you will see carefully, there are maximum 2 or 3 or 4 cells we use. Okay, for battery cells, the small one, cylindrical cells that we can say, DC power. So there is a socket in that particular toy, and we put that batteries in that socket. Okay, positive is connected to positive, negative is connected to negative. Now, have you ever wondered what kind of combination of the cell is? So that we are going to discuss today. So we can also combine the cell in series and parallel combination. Now in this, that E equivalent will be, these are different cells you will see. Okay, so if we arrange it in a single cell, it will become a cell, and then equivalent resistance. So this EMF is the equivalent EMF of the battery, and this R is the R equivalent. So we can also convert this series combination of a cell into a single cell combination. Now what is the value of E equivalent here? So E equivalent is E1 plus E2 plus E3 up to this. And R equivalent, you can say these resistance are connected in series. So R equivalent will be R1 plus R2 plus R3. Got it? Now, these are the two simple formula we can use for it. In this scenario, you will see this is the only combination. Internal resistance is not given here. So we can say we are striking the positive end, then negative. So here E1 is 1.5 volt. In this same case, but here you will strike with a minus plate. So you will take this cell minus 1.5. Got it? Because whenever they are discharging, it will be charging. And whenever they are charging, this cell will be discharging. Got it? So if you are striking in moving left to right, if you are striking the negative end of the battery, take that EMF in minus. If you are striking the positive end, take that EMF in plus. Okay. Now, in the parallel combination, so very simple. If you want to find out in this parallel combination, the E equivalent upon R equivalent, this ratio will remain same. So you can say that E1 upon R1 plus E2 upon R2 plus E3 upon R3, whatever be the number of cells. Now, how to find this one of R equivalent? So these are in parallel. So R equivalent is 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, got it? So this method you can use. From here, You will calculate the value of R equivalent, and from here you put the value of R equivalent in this formula, and R1, R2, R3 you all know. Even E2, E3 is also given in the question. Calculate E equivalent. Got it? Now, if I take an example in this, these are two cells of same EMF and same internal resistance. The EMF of this cell is E, resistance is R, E and R. If I want to find out the potential across it, okay, so how can we find it out? We know that E equivalent upon R equivalent is equals to E1 upon R1 plus E2 upon R2. 1 upon R equivalent, 1 upon R1 plus 1 upon R2. Now R1 and R2 is R, so it will become 1 upon R plus 1 upon R. So 2 upon R. R equivalent will be R by 2. Okay. The E equivalent, if you calculate here, E equivalent upon R equivalent is R by 2. This E1 and E2 is same, so we can take it common. Now 1 upon R1 plus 1 upon R2 will become R by 2 upon R. And this also, this 2 will go upside, it will become 2 upon R. So this will cancel out each other. So in the parallel combination, the potential or the EMF of the cell will not change. So you can make a single circuit of this. This is the battery and this is equivalent resistance. So it will be E, but the resistance would be half. Got it? So try to remember this. In parallel combination of cells, if the EMF of the cell is same, got it? The EMF, equivalent EMF will not drop. Equivalent EMF will remain same and the internal resistance will be half of. Got it? Now, Kirchhoff's law. This is a very simple law. First is the junction rule. Okay. This is also very useful in calculating the numerical, but most nowadays the not so much of the numerical is coming from this topic. So is junction rule says that conservation of charge basically. So if any point or any junction, this is also called as node. So at any node, the incoming current is equals to the outgoing current. So here in the junction, if you will see, this is the incoming current I1, this is the incoming current I2. So at this junction, the out, let's say this is I3. So I3 will be I1 plus I2. Or you can also say sum of all the currents at a particular node or junction will be 0. So you can say I1 plus I2 because they are incoming. So we will take positive and this is outgoing. So I will take it as minus I3 is equals to 0. Got it? So this is the junction rule of Kirchhoff's law. If you will see in this question, this I1 is incoming, I2 is incoming, I5 is incoming, I4 is incoming. So we can say I1 plus I2 plus I5 plus I4 is equals to outgoing, which is I6 and I3. I3 plus I6. Got it? Very simple rule. Got it? Now you can do this numerical. A current of 15 milliampere flows in the circuit as shown in figure. The value of potential difference between the points A and B will be. So in this question, you don't need to apply the Kirchhoff's law because these two are in the parallel and then all the resistance will become in series. So you can easily calculate that. So this is the R equivalent. The circuit will be reduced in this, like this. This is 5 kilo ohm. This is A. This is 10 kilo ohm, and this is P. Okay. This R equivalent will become, I have told you the formula. For two resistors in parallel, we can directly apply 10 into 5 divided by 10 plus 5. So 10 into 5 will become 50 divided by 15. So 50 divided by 15. If you divide it by 5, 5 times are 50, 5 3 is 50. So 10 by 3 ohm, 10 ohm and 5 ohm. This is on kilo ohm, so do not worry about it. So R equivalent now will become 5 plus 10 by 3 plus 10. So this is 3 5s are 15 plus 10 plus 30 divided by 3. So it will become 40 plus 15 is 55 divided by 3. This is the R equivalent. Now we can apply VA minus VB, which is potential across VA A and B. So V is equals to IR, you can say. So V is equals to I. I is 15 milliampere. So 15 into 10 raised to the power 3 ampere. And R is 55 by 3 kilo ohm. So 55 by 3 into kilo ohm, 10 raised to the power 3 ohm. This will cancel out. 3 5 is 15, 5 5 is 25, carry over 2, 5 5 is 25 plus 2, 27. 275 volt is the answer. Got it? A very simple question is this. Now, this is it for today. And whatever the electrical devices we have left, like galvanometer, ammeter, and Wheatstone bridge and potential meter, meter bridge, we will cover this in next lecture, and also uh, solve some PYQs, very interesting PYQs on very conceptual. Till now, if you have any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive, and please try to be on time, because this is the betterment of yours. Okay, the more you attend the class, the more you will gain knowledge in that field. Okay, so any kind of doubt you will have, you can ask. Otherwise, the lecture is being over. Thank you so much.